Alright, here we go again. Starting off with something new again. We've been doing this in class, so I just want to reiterate with actually having let's go over it again with the PowerPoint so we have it on YouTube. So, what are we doing today? We are doing multiplying rational expressions. So, first thing I'm going to do is, like I always do, let's start with the steps. So, the main thing you want to do is protect the binomials with the parentheses and factor. Cancel out the factors on top and bottom that are in common. So if it's on the top and the bottom, you cancel it out. If it's on the top and the bottom, then you do not cancel it out. Then multiply across the top and across the bottom, and then simplify again if possible. So let's go over a couple examples. So first example we have right here. So, like I said with this, what I said earlier, you basically want to go ahead and reduce. Now I'm going to use a method called cross-reduce. And what does cross-reduce mean? Basically, if I have a number going this way that I can reduce, then I can. So, for example, let's look at the GCF going this way, or the GCF going this way. Do we have a GCF going this way with the numbers? Yeah, we do. We have the 7 and the 14. Now the GCF between 7 and 14 would just be 7. So if you divide this one by 7, what do we get? We get 2. Divide this one by 7, we get 1. Now we're going to take these numbers that we have here that I just reduced and then multiply straight across. So the 2 times the 4 will give me 8x squared. We're just going to bring the x squared right over. We're multiplying this times this. Now we multiply across the 1x. The 1x times the 5x will give me 5x squared. Now, like I said earlier in the steps, if we have something on the top and the bottom, we want to just cancel it out. And what do we have on the top and the bottom? We have an x squared on the top and an x squared at the bottom. So we're going to go ahead and cancel that out. And now we're left with just 8 over 5. Alright? So, here's the answer for the first one. That one was pretty simple. We didn't have to really factor anything, we just basically cross-reduced. So let's go into another example. Alright, example 2. Now this is basically the same thing we've been doing when we simplify and we factor. But the only thing you gotta look at is we have a top, we have a bottom. As for the first one, and the top and the bottom for the next one. So what you want to really focus on, is trying to reduce everything down as far as possible. So let's look at the top part. Can I reduce that down any further? No. The reason why we can't is because this is a whole thing. So this would be x plus 2. I'm going to leave that the way it is. Now, at the bottom, can I do anything to this? What we've been doing from before, this is a binomial, and we have two things. Something that can be pulled out of this would be, for example, we have 2, we can pull the GCF out. The GCF of 3x and 6 would just be 3. So we pull it out, and we get x, 3x plus 2. Now, of course, you're going to say I can go ahead and cross that out, but let's not. Let's go ahead and continue on, and then we multiply across, and then we reduce. So let's go ahead and finish this out. Can I reduce this anymore? No. So I'm going to leave that as a 6. And I'm going to leave this as a x. Now, is there anything I can cross out of here? Absolutely. I can do the x plus 2 and the x plus 2 because these are both one thing. This crosses out, and I'm left with just multiplying straight across. This is already gone, so I'm going to do 6, and then I'll multiply this across. This is gone, so I just get 3x. Now, can we reduce this any further? Yeah. We can say 6 divided by 3 gives me just 2, right? So 2 over x. And we have our answer right here. So we simplify it down as far as we can. After we're done simplifying it down, we cancel stuff out. And then when we're done canceling out, we multiply across. And then, if possible, simplify again. Alright? So let's go. That's example 2. Let's go to example 3. Example 3. Now this one looks a little bit more complicated, but actually it's the same thing we've been doing. So I'm going to look at this first. Can I break this one down? Yeah, I can. I can factor it out. So it's a binomial, so I know I don't have to use, I can just use factor GCF. So I'm going to factor this out using my GCF, which will give me, well, we'll go into 5x and then 10, 5. So I'll pull the 5 out, and I get x plus 2, right? Now put that over. Can I factor this out any further? No. So I'm going to leave this at x plus 3. Next one, can I factor out the top any further for this one? Now, yes I can. I can do difference of squares, because we have a negative here, and we have a perfect square here, and we can do the square root of this. So this will just give me x plus 3, and then x minus 3 over, now can I break this one down any further? No. So I'll leave a 5 here. Now, I'm going to jump right into looking at what I can cancel out. I have x plus 3 here and an x plus 3 here, so I can cancel that out. That goes away. Now also, can I cross reduce anywhere? Yes, I can, the 5 and the 5. So this can't, divide this one by 5, divide that one by 5, I get 1 here. That's a GCF going this way for the numbers. Now what's left over? What's left over is just this right here and this right here, and we don't have anything at the bottom. So now I multiply straight across, which gives you x plus 2 times x plus 3 over 1, which really is equal to x plus 2 over x plus 3. Alright? And that's what we got. So this is your answer here. We're good. If you want to multiply it out, that's fine, but more than likely, you're going to get the answer choices. It will be just this alone. Alright? Now, so we on example 3. Let's go one more. Give me one more example. I think I might have 2 actually. Alright, so now we're getting a little bit more complicated. What do we have at the bottom? We have a trinomial. Whenever we have a trinomial to the second power, what method do we use? We use x, right? So let's break everything down. Can I break this one down any further? The top part? No. I just do x plus 4. Can I break down the bottom part any further? Absolutely. We're going to use the x. So using the x, I do 1 times the 4. It gives you my 4 here. I bring the 5 at the top. Now just to let you know, you can switch these around as long as you know I need to add at the top and multiply at the bottom, or whichever way you want to do it. So this will give me 5. This will be multiply right here, and this will be add right here. I set mine up this way. Some people do the opposite way. So what numbers will multiply to give me 4 and add to be 5? That should be real easy. It should just be 1 and 4. So this should be x plus 1 and x plus 4. And now I'm going to do a multiplication sign. Now, let's look at this. This is basically just 3x plus 3. Is it really a fraction? Yeah, it is, actually. It's just 3x plus 3 over 1. Which is really always, yeah, it's basically always a fraction. So now what can I do to this problem right here to break it down? It's got 2, so I know I can either the GCF or difference of squares. So I'm going to pull the 3 out because it's GCF. 3x plus 1 over 1. Now, what can we do now? What can we cancel out? So let's go back and let's see what we can cancel out. This is on top, this is on bottom. Cancel this out, cancel this out. This is on bottom and this is on top. And what am I left with? I'm just left with the 3 and the 1. So 3 over 1, which just gives me 3. That's my answer. Alright? Alright. So we get one more. I think I have one more. Nope. That's, well, that will be it. This is the last example I have. So we'll stop there. Hopefully this will help you out. If you have any more questions, please ask me, Miss Black, or Miss Glover. Basically the simple steps of using your multiplying the rational expressions. Like I say again, simplify. First of all, you want to break it down, which means basically simplify. Whatever you have in common, the top and the bottom, you cross out, and then you multiply across, and then if you can, you cancel it out. That's all you have to do. So use the concept of factoring to make this easy. Like I said, also try to use your cross reducing if you can, and that sums up everything. Please go over these problems again with me, one by one, and try to do them again on your own. And I believe if you get it down, you should be good to go.